Now I'm going to show you how you can calculate the time required to run an algorithm. So instead of using a stopwatch on your phone or on your mobile device, we are going to write a program which will give us the time it took to run a certain algorithm. And in this case, I'm going to write the bubble sort algorithm and then find the time it took to execute the bubble sort algorithm. So for this, I'm going to say my lower limit will be 5,000. So I'm going to generate random numbers between minus 5,000 and 5,000 into the array. And let's say that my array size is 10,000. So it can hold 10,000 integers between minus 5,000 and 5,000. So we can change this to 99999. Yeah, 9,999. So this code will help us to fill the array with random numbers between the lower limit and the upper limit. Now next, let's implement the bubble sort algorithm. So we have already seen this before. So for I equals to 1 to I less than or equals to, let's make this as n equals to 10,000, int n equals to 10,000. I can say this as n minus 1. I less than or equals to n minus 1, I plus plus. Then for j equals to 0 to j less than or equals to n minus 2, j plus plus. Include j in your list of variables. And also we need a temp to make the swap. So if a list of j is greater than list of j plus 1, then swap. So list of temp equals to list of j. List of j equals list of j plus 1. And then list of j plus 1 equals temp. Okay, so this is the bubble sort algorithm. Bubble sort. Now I want to find the time it took to execute this algorithm for a list of 10,000 numbers between this range. So how do we do that? So there are a few variables that we can use. You don't need to by heart this. It just comes by practice. So the first variable is clock underscore t. This is defined in time.h. Start comma end. So start and end are two variables of the type clock underscore t. And then I'm going to say double CPU time used. So a double is an extended floating point number. So you know that a floating point number occupies 4 bytes in memory. A double occupies 8 bytes in memory. So you can store a larger value in a double variable. Okay. So what I'm going to do is just before I start my algorithm, I'm going to start the timer. So start equals current time. And then once my algorithm is done, I'm going to say end equals capture the current time. And then I can say CPU time used equals double. So that's a typecasting. End time minus the start time divided by clocks per second. Again, clocks per second is defined in time.h library file. So it is going to come. So your CPU runs on a clock, typically 2.4 gigahertz clock. So it's going to take that as well. And then I can say printf time taken equals percentile f seconds, comma, CPU time used. Let's run this, save and run. It's going to take some time. So it took around 0.35 seconds. Now I can increase the size of the array. So I can make this as 100,000 elements and rerun the code. Let's see how much time it takes. Okay, meanwhile, while it's running, so it's not like when you deal with programming, you will know everything or you will be taught everything. So some things like these, you just have to, learn it up. You can go through online forums and see how people are solving problems. And then you can get an idea and then implement that idea in your program wherever required. So you can see here that it took 35.87 seconds to sort 100,000 elements between this range. So that's the total time it took to implement bubble sort.